Welcome to Echo 204, Study Session 10, Constrained Optimization, the Lagrange Multiplier Method. Solutions to economic problems usually have to be found under constraints, e.g., maximizing utility subject to budget constraint or minimizing cost subject to minimal requirement of output. The use of Lagrangian function helps to solve this. The constraints represent restrictions that can influence the degree to which an objective function is optimized. Constraints may reflect such restrictions as limited resources, e.g., labor, materials, or capital, limited demand for products, sales goals, etc. Problems having this structure are considered to be constrained optimization problems. Generally, we optimize y equals f of x1, x2, subject to g of x1, x2 equals k, where f of x1, x2 is the objective function and g of x1, x2 is the constraint. To solve, we set up a composite function known as the Lagrangian function. Thus, L of x1, x2 lambda equals f of x1, x2 minus lambda g of x1, x2 in bracket minus k. The variable lambda is known as the Lagrangian multiplier. Notice in the Lagrangian function that lambda can equal any value, and the term lambda of g of x1, x2 in bracket minus k will equal 0, provided that x1, x2 are values which satisfy the constraint. Then we can take the partial derivative of L of x1, x2 lambda with respect to x1, x2 and lambda and set them equal to 0. That is, Lx2 equals 0 and L lambda equals 0. We then solve the equation simultaneously. Example 1. Maximize f of x1, x2 equals 25 minus x1 squared minus x2 squared, subject to 2x1 plus x2 equals 4. Solution. The Lagrangian function yields the following transformation. L of x1, x2 lambda equals 25 minus x1 squared minus x2 squared minus lambda of 2x1 plus x2 minus 4. Taking the partial derivative, we have Lx1 equals minus 2x1 minus 2 lambda. Lx2 equals minus 2x2 minus lambda. L lambda equals minus 2x1 minus x2 plus 4. Critical values are found by setting the three partial derivatives equal to 0. Minus 2x1 minus 2 lambda equals 0, which is equation 1. Minus 2x2 minus lambda equals 0, that's equation 2. Minus 2x1 minus x2 plus 4 equals 0, that's equation 3. Multiply equation 2 by 2. That will give us minus 4x2 minus 2 lambda equals 0, equation 4. Subtract equation 4 from 1. That will give us minus 2x1 plus 4x2 equals 0. 2x1 equals 4x2. x1 equals 2x2. Substitute x1 equals 2x2 into equation 3. Minus 2 of 2x2 minus x2 plus 4 equals 0. Minus 4x2 minus x2 plus 4 equals 0. Minus 5x2 equals minus 4. x2 equals 0.8. Since x1 equals 2x2, x1 equals 2 of 0.8, x1 equals 1.6. To find lambda, substitute into either equation 1 or 2. Minus 2x2 minus lambda equals 0. Lambda equals minus 2x2. Lambda equals minus 2 of 0.8. Lambda equals minus 1.6. The maximum value of the objective function can also be found. F of x1, x2 equals 25 minus x1 squared minus x2 squared, which equals 25 minus 1.6 squared minus 0.8 squared, which equals 25 minus 2.56 minus 0.64, which equals 21.8. What does lambda, the Lagrangian multiplier, means? Lambda shows the extent to which the objective function changes when the constant part of the constraint changes by 1 unit. From the example above, if the constant in the constraint increases by 1, the objective function will reduce by 1.6. Example 2. What combination of goods X and Y should a firm produce to minimize cost when the joint cost function is C equals 6x squared plus 10y squared minus xy plus 30, and the firm has a production quota of x plus y equals 34. B. Estimate the effect on cost if the production quota is reduced by 1. Solution. L equals 6x squared plus 10y squared minus xy plus 30 minus lambda of x plus y minus 30. Lx equals 12x minus y minus lambda. Ly equals 20y minus x minus lambda. L lambda equals minus x minus y plus 34. Equate to 0 and solve simultaneously. 2x minus y minus lambda equals 0 as equation 1. 20y minus x minus lambda equals 0, that's equation 2. Minus x minus y plus 34 equals 0, that's equation 3. Subtract equation 1 from equation 2. Minus 13x plus 21y equals 0. 13x equals 21y. X equals 21y divided by 13. Substitute x equals 21y divided by 13 into equation 3. Minus x minus y plus 34 equals 0. Minus 21y over 13 minus y equals minus 34. Minus 21y minus 13y divided by 13 equals minus 34. Minus 34 equals minus 442, y equals 13. X equals 21y divided by 13, y equals 21 divided by 13 times 13, x equals 21. Solve for lambda in equation 1. 12x minus y minus lambda equals 0. 12 of 21 minus 13 minus lambda equals 0. 252 minus 13 equals lambda. Lambda equals 239. The minimum value of cost, C, equals 6x squared plus 10y squared minus xy plus 30. C equals 6 of 21 squared plus 10 of 13 squared minus 21 of 13 plus 30. C equals 4093. B, with lambda equals 239, a unit decrease in the constant of the constraint will lead to a cost reduction of approximately 239. Example 3. A monopolistic firm has the following demand function. for each of its products X and Y. X equals 72 minus 0.5 px, Y equals 120 minus py. The combined cost function is C equals x squared plus xy plus y squared plus 35. And maximum joint production is 40. Thus x plus y equals 40. Find the profit maximizing level of A, output, B, prices, and C, the maximum profit. Solution. Px equals 144 minus 2x. Py equals 120 minus y. Trx equals 144 minus 2x in bracket times x. Try equals y of 120 minus y. Tr equals trx plus try, which equals 144 minus 2x in bracket times x plus y of 120 minus y. Profit therefore equals 144x minus 2x squared plus 120y minus y squared minus x squared plus xy plus y squared plus 35, all in bracket. Profit equals 144x minus 2x squared plus 120y minus y squared minus x squared minus xy minus y squared minus 35. Profit equals 144x minus 3x squared minus xy minus 2y squared plus 120y minus 35. With the constraint L equals 144 pi minus 3x squared minus xy minus 2y squared plus 120y minus 25 minus lambda of x plus y minus 40. Lx equals 144 minus 6x minus lambda. Ly equals minus x minus 4y plus 120 minus lambda. L lambda equals minus x minus y plus 40. Equate to 0 and solve simultaneously. 144 minus 6x minus lambda equals 0, which is equation 1. Minus x minus 4y plus 120 minus lambda equals 0, which is equation 2. Minus x minus y plus 40 equals 0, which is equation 3. Subtract equation 1 from 2. 5x minus 3y minus 24 equals 0, which is equation 4. Multiply equation 3 by 3. Minus 3x minus 3y plus 120 equals 0. Subtract equation 4 from 5. Minus 8x plus 144 equals 0. 8x equals 144, x equals 18. Substitute x equals 18 into equation 3. Minus x minus y plus 40 equals 0. Minus 18 minus y plus 40 equals 0. Minus y plus 22 equals 0. Y equals 22. Substitute x equals 18 and y equals 22 into equation 1. 144 minus 6 of 18 minus 22 minus lambda equals 0. 144 minus 108 minus 22 minus lambda equals 0. 14 minus lambda equals 0. Lambda equals 14. B. Px equals 144 minus 2x, which equals 144 minus 2 of 18, which equals 108. Py equals 120 minus y, which equals 120 minus 22, which is equal to 98. Profit equals 144x minus 3x squared minus xy minus 2y squared plus 120y minus 35, which equals 144 of 18 minus 3 of 18 squared minus 18 of 22 minus 2 of 22 squared plus 120 of 22 minus 35. Profit equals 2,861. Exercise 1A. Minimize cost for a firm with the cost function C equals 5x squared plus 2xy plus 3y squared plus 800, subject to the production quota x plus y equals 39. B. Estimate additional cost if the production quota is increased to 40. 2a. Maximize utility. U equals Q1 times Q2 plus Q1 plus 2Q2, subject to 2Q1 plus 5Q2 equals 51. B. What happens to the consumer's utility if its budget changes from 51 to 56? This is the end of study session 10. Thanks for listening.